Alright, here is trig test 3b. So, what we need to do here is solve for all the missing sides and angles of each triangle. So, let's start out by drawing a picture. One thing to keep in mind here, when it tells you angle A is something and side A is something, those two somethings have to be across from each other. So let's say the 70 is here, and you could put it in any corner. What matters is that the 10, the side that's also called A, is across from it. And then some other side is called B, which is 7. Sorry, I'll just put it as 7. Okay, so we have some arrangement like this. The 7 could go here, it could go there. It would essentially be the same triangle, just facing a different direction. Now, to solve this, we need to find first one of these other angles. We can't use the Pythagorean theorem because this is not necessarily a right triangle. So, how do we find one of these other angles? Well, let's call this angle across from side B angle B. So what I'm going to do is set up a law of sines. So we use the law of sines when we have pairs of opposite sides and angles that we can work with. That's the situation here. So I'm going to say 10, and I'm going to compare that to sine of the angle across from it. So that ratio is the same as the ratio of this 7 to the side, to the angle across from it, which we don't know. So that's sine of B. Now, we're going to cross multiply here and then divide. So 10 times sine of B, that's multiplying across this way, and then 7 times equals 7 times sine of 70. And now to solve for B, I need to divide by 10. So divide by 10, and then my answer for B is going to be the inverse sine of whatever this decimal is, which I should calculate. I'll be right back. Okay, I brought in a helper. So, the first thing we're going to do is calculate this side. 7 times sine of 70, which reminds me I should check what mode I'm in. So press mode, and okay, I'm in degree mode. Good. So 7 times sine of 70 divided by 10. That's going to give me some decimal. Now, to get B, I need to do the inverse sine of this decimal. So I can do that in the calculator. Inverse sine. And then, if you still have your calculator, you can type in that number again, or you can do second and then by the negative sign it says A and S, which is the last answer. It'll plug it in for you. So sine inverse of that last answer, so we get an angle of about 41 degrees. Okay, and that angle is across from the side B, across from the 7, based on the way we set it up. So we can find this third angle because we know what the three angles in a triangle should add up to. They should add up to 180. So I'm going to start with 180 degrees, then subtract out the 70, then subtract out the 41 to see what's left over. What's left over? 69 degrees. Okay. Now I need to find this third side of the triangle. And again, it's not a right triangle. We know that for sure now. So the Pythagorean theorem is not going to work. One thing I do know, if this angle is 70, this angle is 69, then the side across from it should be a little bit less than 10. This angle is 41, and it's got a 7 across from it, so the side across from the medium size angle should be the medium size side. So big angle, big side, little angle, little side, medium angle, medium side. So it should be somewhere between 10 and 7. So again, we're going to use the law of sines. So if I'm looking for this side, we could call it C. Then I'm going to set this up as C compared to sine of its opposite angle. and that equals, and I can use either pair here. I'll use the 10 divided by sine of 70. And I'm going to solve it in my calculator just like before. So here, and I'm going to multiply by the sine of 69. So I've got 10 times, back to the calculator, 10 times sine of 69 degrees, that's on the top of the fraction, divided by sine of 70 degrees. And what do I get? I get 9.9. Okay, next problem. Now this time, I don't have any pairs of opposite sides and angles that I can start with, so I have to use the law of cosines. And you can still use this to solve for an angle. What we're going to do is leave this big C, which is the angle, as our unknown, and then plug in sides A, B, and C here. Now, the trick is, notice this is called C, and this is also called C. So because both of these are C's, that means they are a pair. They go opposite from each other. This is side length C, and this is angle C. So depending on the way I set this up, I'm going to be solving for a different angle. Let's say I use the 7, the big side, as my C over here. That means I'm going to be solving for this angle across from it. Okay, so I'm going to set this up like so. So the C squared would be the 7. Oops. So that's 7 squared. And then the A and the B would be the two other sides. So let me fill this in. So that's 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times cosine of something. We don't know what that angle is. So we've got to solve for that. Okay. So now we're gonna square these numbers, combine some like terms, etc., etc. So here we get a 49. That's 25, and that's 36. Add them together, and you get 40, 50, 61. And over here, that's 2 times 30, so minus 60 cosine of C. And again, we're solving for this angle C. So instead of subtracting these, we need to subtract the 61 over to the other side. So subtract 61 from both sides, that'll give you a negative 12 over here. So negative 12 equals negative 60 times cosine of C. Then divide, and you'll get 1/5. So 1/5 equals cosine of C. And if you want to see this work in a easier to read place, go look at the scans where I worked it out on a blank sheet of paper, and there was a little bit more room. Now, from here, I'm going to do the inverse cosine. So grab your trusty calculator, and inverse cosine, inverse cosine of 1/5. So in other words, what angle has a cosine of 1/5? That's the question. And the answer is 78. And that'll be 78 degrees, because I'm in degree mode. Now, once I have this, I have a pair of opposite side and angles that I can use. And so from here, I'm going to use, time to go. I'm going to use the law of sines. So I can say 7 compared to sine of 78 equals, and if I want to find the angle across, say, from the 5, then I can say 5 over sine of whatever you want to call that angle, maybe B. 5 over sine of B. And now I'm going to solve this as mentioned previously. So if you're confused about this part, go back and look at what we did right here. We're going to do the same process. So we're going to end up with sine of b equals the 5 times the 78 and divided by the 7. And then you're going to grab your calculator and type it in. So I'm going to type this all in at once. I know I need to do the inverse sine, and then in parentheses I'm going to put 5 times sine of 78 divided by 7. 44 degrees. And because I have 78 here and 44 degrees there with a little bit of subtraction, subtract both of those from 180. I'm using my calculator. And there are 58 degrees left over. Okay, now I'm going to flip it over to the back.